Here's some solutions to the worksheet that I handed out on section, which section is this? 1.5 and 1.6. This is where we're developing our derivative rules. And this is just solutions to problems that we did not go all the way through to the end in class, so you have this as a reference. The problems on practice 2 are the question is to produce a tangent line to the graph for each of these two problems. And what we learned was that what we need to find first, in order to find the equation of the tangent line, is to first find the slope of the curve at the point, which we get by computing the derivative. So in this case, the function is x over 3, which is the same as 1/3 x, plus 3 over x, which is the same as 3 times x to the minus 1. So we talked about this in class. We did one like this, where we want to rewrite fractions so that it's 1 over the denominator times the numerator. So here I have the x is the numerator times 1/3. So x over 3 is the same as 1/3 times x, and 3 over x is the same as 3 times 1 over x, and 1 over x is the same as x to the minus 1. So this is just an algebraic rewrite, but you can see that this now makes our function written as a number times the power of x plus a number times the power of x, and that's what we need for the power rule. So in that case, the derivative is 1/3. The derivative of 1/3 x is just 1/3, and the derivative of x to the minus 1 is minus 1 times x to the minus 2. So that is 1/3 plus, I guess I should say minus, I have a plus, a negative 1, so minus 3x to the minus 2. So this is my formula for the derivative, which means that the derivative at this point, this is the point where x is 4, so f prime of 4 is going to give me the derivative at this point, and the derivative at this point will be the slope. And we can tell from looking at it that it's going to be a very small number. Remember, a slope of 0 is horizontal, and this slope is almost horizontal. So f prime of 4 is 1/3 minus 3x to the minus 4. Sorry. It's late. 3 times 4 to the minus 2, and that is approximately, I'll write as a fraction. This is 1/3 minus 3 over 16, which is 13 over 48. So it's a fraction. You can put that in a calculator to find out what that is. It's about 0.3, but more than a quarter. Okay, so that's the slope, and so we learned that the equation of the tangent line is going to be y minus a y-coordinate that we know, so I need to know the y-coordinate at this point, is equal to the slope, so that's 13 over 48, times x minus the x-coordinate of the point we know. We know the x-coordinate here is 4, so that's easy. And the number for the y-coordinate that we would get, again, I might as well just use a fraction. Going back to my original equation here, if I calculate f of 4, that is going to be 4/3 plus 3/4, which is 25 over 12. And so that is the y-coordinate, 25 over 12. It's a little bit more than 2, and you can see that makes sense. So 25 over 12. So this is a perfectly good way of writing the tangent line to the curve. That'll be the equation of the curve right there. It'll look like that. And again, 13/48 is the slope, and that's about a little bit more than 0.25. So it makes sense that that should be a very, very shallow line. The second question here is much easier because the derivative is easier. In this second problem, the derivative is just 2x minus 4, and so at this point, at the point that I'm interested in, this is the point where x is 0, and so f prime of 0 is negative 4. So the line where it goes down like this, that goes in the same direction as the curve, has a slope of negative 4. And so, therefore, let me just give myself a little room here. Therefore, the equation of the tangent line will be y minus the y-coordinate here, which is 3, is equal to the slope, -4, times x minus the x-coordinate here, which is 0. So that is okay as the equation. It's very easy to write that and in slope-intercept form. If you prefer, this one requires a little bit of work with fractions to be able to write that in slope-intercept form, but it's not too bad. And the only reason for writing it in slope-intercept form is that that would be an easier expression to put in a calculator to draw the graph or something. But if there's nothing else you need to do with it, then these two answers, the form of those two answers is perfectly fine.